preserved by doing this process. And because of this, the further treatment process, either in water treatment and the wastewater treatment, the pollution load and the complication will be reduced. And because of that, the aeration will improve the quality and enhance the taste and odor and support compliance with the regulatory standard and more economically in wastewater treatments. And it sustain the biological activity by supplying dissolved oxygen that is in the form of air. And majorly, this water will be reducing around 60% of pathogens from the aeration process. Clear? Now we'll talk about what are the application or uses of aeration. I told you that it is removing all the dissolved gases. I said I don't want to talk about much. I think so I have explained clearly. And beyond that, in water or in fresh water or in groundwater is polluted or not? Coming fast, very fast, then I can go ahead very fast. Now you please tell me, groundwater is polluted or it is not at all polluted? It's clear water. What is the opinion in general?
It's polluted, but
it's polluted. Why it is polluted and how it is polluted?
mainly because of water runoff.
Water runoff.
Yeah, water runoff because of excessive use of fertilizers, pesticides.
Okay.
That is percolated into the groundwater.
Okay, fine. Then
water runoff.
Even salt water intrusion also leads to.
Yeah, water intrusion is there. But these are all, whatever you said, both of you are said it is correct. It is not wrong. All these point, whatever we are discussing, don't discuss and leave. All these are your subject. You can write, note it down this point in exam also. If they are talking about groundwater pollution or water pollution, you can write all these points. These are all answer. Okay. Whatever you said, it is correct. But these are all not occurring all the places. Is it only in selective places? Where the agriculture field is there that percolation will be there. Wherever sea and nearby sea basin or coastal area, this intrusion will be happening. It is not happening in Rajasthan, correct? Or it is not happening in Hyderabad city, is it? But Hyderabad, does it mean that Hyderabad underground water is not polluted? No, it is polluted. So what could be the other reason? Yes. Why we are having the water filter at home? Everybody is having tasty water. That's what we are having, is it?
To remove the impurities and make it clear.
So are you using pure bore water or corporation water?
Bore.
Bore water. So where are you getting the impurities?
Because of the minerals, the salt content.
The total dissolved,
yes,
total dissolved salts.
This is hard water we are filtering, no?
So you are telling that salt, whatever is there in water, it is not good for health. That's what you want to remove.
Regarding
the total dissolved solids, TDS, is an important factor that has to be, that we have to reduce, madam.
Okay, what is the permissible limit of this TDS?
Yeah, around 150 to 300 ppm.
Okay, fine. Is it more than that in your water?
Yeah, definitely, madam. Bore water has more than 1,000.
Really?
It depends.
I
Yeah, it depends on the.
In Hyderabad, sir.
What, madam?
I never heard that it's more than 1,000 in Hyderabad. In which area is it?
So yeah, I am from Guntur, madam.
Okay, fine. Then obviously it might be. Okay, fine. Now I'll come to
yeah, we the moment.
Yes, sir. Whatever you said, all are reason, but specifically I wanted to tell for your clear information and also personal or professional information. I am telling whatever the water we are drinking from our water filter is not at all good for health. The reason behind that, water means we are taking H2O is not good. Whatever the food we are taking, whatever our intake, totally I am saying intake, either solid, liquid, whatever it may be. Water is the one of the good nutrient supplier than anything else. Because some of the mineral must be there in water that will be there in our natural resource water. When you are doing this RO processes, specifically reverse osmosis process, what is exactly happening? Whatever the substances, not only mineral, whatever the substances, it may be suspended impurities or it is soluble impurities. Those will be filtered it off from the water. So whatever the essential, including essential minerals, will be removed from that water. When we are drinking that water, whatever the body required minerals, either for our bones, teeth, joints, enamels, hair, eyes, and eyeliner, everything will be reduced. Because of that only, if you take the entire history from 2000 onwards, or the 19th century to 21st century, if you take, we have that efficiency of all these things. One of the reason behind that, because we are drinking this filtered water, all the essential mineral is removed. So what people are having leg pain, teeth damages, bone damages, hair losses, eye losses, many things are happening. So what could be the good source of water? Only the good source of water is you have to drink that boiled, not warmed. Boiled corporation water or municipal water is very good for drinking. And more specifically, I am telling you, Hyderabad is, by grace of God, we are getting very good water. We boil it and drink it, it is more than enough. And I can say anywhere I am ready to come and tell whatever the water filter they have introduced many model, many features, many texts. All together I am saying they are all removing all essential minerals, and because of that 90% of people, those who are consuming that water, they are getting such a problem in their 50, 60, 70 years old conditions. You go to the hospital, you check it, you check the probability and the statistics, you can understand that is true. Now, people do not know that what problem is coming from the underground water. The underground water is not good. The reason behind that, whatever the decomposable gases are coming out, whatever I told you, those gases are there. What are the sources for those gases? Whatever the littering will go underground. That leaf litter, animal body, human body, everything we are putting into the soil. And that also will undergo decomposition. When it undergoes decomposition, wherever the nearby water bodies will be there it will be dissolved. And those gases, when it dissolved, what will happen? It will be there in water. This is one. And another thing is iron and manganese. I'll come to the point, iron and manganese. These two are the elements which gives color and also taste to the water. What is the color iron and manganese? We know that when you are cutting the brinjal, if you leave it for some time, the brinjal color will turn into brown color. What is the reason? The iron will become iron oxide. Similarly, the manganese will be converted into or oxidized into manganese oxide, manganese dioxide. These two components, either iron trioxide or iron hydroxide, or ferric hydroxide and manganese dioxide, these two are highly soluble in water. Those imparts the taste also to the water and also which gives this color also to the water. Like that, each and every mineral is giving some advantages and the disadvantages to the water along with the dissolved decomposable gases. All these decomposable gases are coming from decomposed organic matter which are all in the soil. So all these gases are all, what I said, those are all organic gases. Some of them, carbon dioxide and hydrogen sulfide, will reduce the pH, that will gives the acidity to the water. And those will give the corrosive problem to the water. Ammonia will interfere the chlorination, or why it interfere the chlorination process? Chlorination means what? We are killing the microorganism, that is chlorination. But ammonia will be there. Ammonia and chlorine both will combinedly make the amines compound and amide compounds. This amine and amide both will become a pollutant to the water. Is it clear? These are all the things happening. That's what we supposed to remove all these dissolved gases and also the solubilized minerals like iron and manganese. These things are happening when you are doing this aeration process. Is it clear? Hello? Hello? No one is there in the class.
Yes, ma'am.
I'm talking for myself. Is it clear or is it confusing? Shall I tell one more time? Okay, then go ahead. So this iron and manganese are naturally occurring metals in the underground, and those are all in the ionized form Fe2 plus and the Mn2 plus. And this is not a harmful chemical, but this will gives only staining and sometimes which will give some color and which makes a problem in the pumping system, and it will be supporting to the growth of microorganism. And when we are doing this aeration process, when we are supplying excess oxygen or excess air
Even
into the this
kidney
iron.
disease also.
Hello,
Even it may damage kidneys also.
what is that? No, ma'am, I cannot hear your voice. Can you little
Due to
louder, please?
the heavy metal exposure, madam, kidney disease also can be occurred,
No,
right?
no, heavy metal is different. Heavy metals is different. Heavy metal means what? The atomic weight more than 20 and the specific gravity should be more than 5. Those are all called heavy metal. Those heavy metals will not interfere in this process. Clear? Somewhere some of the reserves are there in underground that may be some mercury, copper, and bismuth, lead. Those reserves are there. They may be possible to solubilize or make a compound, and compound form it will be available. Whatever I am speaking, widespread everywhere, whatever is there, I am telling. Whatever you said heavy metal, it is not available everywhere. Somewhere here and there, wherever the mines and the reserves are there. Clear? If it is there, then it is problematic. You can note
Okay.
it down, but specifically you have to write. In case somewhere that resource is there, that will make a such a issue. You can write. No issue at all.
Okay.
Okay. And this iron and manganese will be oxidized to manganese dioxide and iron hydroxide, and which is insoluble, and it can be easily removed by either. It is not soluble, so it makes a precipitation. Then that precipitation can be easily removed by sedimentation or filtration process. And what they are doing, and iron oxide, it proceed rapidly at neutral pH, but always this manganese oxidation, which is much slower, and it practically at very high pH around more than 9.5. For this reason only, the strong oxidations such as fluorine and potassium permanganate and ozone, all these substances people are sometimes applied along with the aeration process to remove this manganese. And also, this aeration is fundamentally first step to remove the iron and manganese. Otherwise, this presence of this will affect the further process. As I told you that if iron is more, which supports the growth of microorganism, and manganese is more, which imparts the color and staining. To avoid this problem, the manganese ion supposed to be removed in the first step itself. That's what people are following this aeration process prior to sedimentation process. And this facility people are following specifically whenever they wanted to treat the groundwater, that time only. And in surface water, iron will be there, manganese presence will be less. So no need to do further. And the second steps already I have discussed about that removal of solubilized gases or dissolved gases. Whatever the gas I told you, carbon dioxide, methane, hydrogen sulfide, and ammonia, all these gases are coming from the decomposition process of organic matter, and all these gases supposed to be removed from the water by this aeration process. If ammonia is there, I told you how it affects the aeration process and the disinfection process. Keep all these points in mind. If disinfection they will ask, you can write this process. Aeration they will ask, you can write all this process. It is very, very important. And aeration effectively remove these particular gases. And following the or according to the Henry's law, the solubility of these gases which depends upon the partial pressure in the atmosphere, because we are supplying air from the atmosphere, and based on that pressure only, these gases could be removed. Either it is absorbed or it could be stripped. And removal efficiency of these dissolved gases depending upon the few factors, that is turbulence, air to water ratio, contact time, and the temperature. Because we know that if the temperature increases or decreases, the volatile organic compound will be expelled out. So the temperature plays an important role. Contact time, which provide the air-water interfaces. Air to water ratio supposed to be more, means more water air ratio is there, there will be a formation of more interface. If more interface is there, the contact time will be more. If more contact time will be there, there will be the removal of more dissolved gases, then the aeration efficiency will be increased rapidly. Then CO2 stripping improves pH stability and also which reduces corrosiveness. Hydrogen sulfide removes odor and it reduces the corrosion. Ammonia stripping increases, or this ammonium salt converted into gaseous ammonia means it will be better. It is highly volatile in nature. It will be removed. Or until or otherwise, it makes the chloramine, means when it is complicated, then chlorination process and disinfection process cannot be done, or it reduces the efficiency of such a process. And the third important process steps which is useful for this aeration process, odor and taste control. How this odor and taste control will be played here? Already I told you that the presence of iron and manganese which gives color and taste. And odor means the odor will be coming from the hydrogen sulfide and volatile organic carbon. Those things, how it could be removed from this process. So odor and taste, how people are using. The odor is coming from the hydrogen sulfide and organic volatile compound and some of the algal growth, and these things will be removed by the aeration process. And the taste is coming from the iron and manganese, and it will be imparting that, and before it converting into iron hydroxide or ferric hydroxide and manganese dioxide. Otherwise, this will be eliminated. The taste and odor concept will be eliminated. So what in many of the municipal or corporation water supply system, they are following aeration unit and with treatment plant which is free from the offensive taste and odor, thereby improving the consumer acceptability by following the removal of hydrogen sulfide and volatile organic compound. And the completely volatile organic compound removal, how to do. What are the sources of volatile organic compound in groundwater? Hello? What are the sources of volatile organic compound? Any one of you there or not? Are you there? Hello?
Yes, ma'am.
What happened? Not interested. Subject is not interested.
No, madam, it was interesting. We are following.
No, if you do like this, then I will lose my interest to explain more. Obviously, yes.
You are asking about what is the source of volatile organic compounds.
Yes, yes. Because now we are talking about what aeration process is doing. First, I said which removes the dissolved gases. Second, I said which maintain the manganese and iron ions to reduce the color and oxidation thing. And the third, odor and taste. And the fourth one is volatile organic compound. So now we are, what is happening? The aeration process removes the volatile organic compound. I told you already. Because this what is volatile organic compound? Organic compound which are, what is volatile organic compound? Volatile organic compound means what?
Carbon containing gases, madam.
Carbon containing?
Gases.
My goodness. Oh, sorry. Then
No.
volatile means
They actually said, madam, this environmental science is actually a multidisciplinary, and the learners we are also from different background. For suppose I am from geology background, so I'm not that much exact
understand,
about.
because simply studying volatile organic carbon and writing exam and getting the mark instead of that, you can understand that volatile organic compound means what? Volatile means what? The volatile means anything will be evaporated at the room temperature, that is called volatility. Volatile. Anything. If you take petrol or diesel or kerosene,
Either in indoors and outdoors.
yes ma'am? Any compound which evaporate at room temperature, those compounds are called volatile compound. That is called volatile compound. So volatile compound means petroleum, diesel, alcohol, you just open and keep it outside. Will it evaporate or not?
Yes, ma'am.
Yeah, those compounds are called volatile compound. So the all volatile compound. Volatile means the compound or the substances which evaporate at room temperature is called volatile organic compound. Those are all waste from the organic region. So volatile means easily evaporable. Those easily evaporable compound from the organic region means that is called volatile organic compound. Those volatile organic compound or organic compound is very important to understand in this water and wastewater treatment paper. Without understanding that, if you study volatile organic compound removal, aeration process is removed the volatile organic compound and no use at all. You should understand what is what. So if you can't understand, you can question me, I will explain. That's what I am telling right from the starting. Since you are doing PG, you should be able to talk about the substance more than half an hour without any hindrance. So if you understand and follow me clearly, if you can't understand and you can't follow, you ask me the question immediately, I'll clear it out. It's not every 10 minutes once, 15 minutes once I'm asking, you could able to follow me or not. Okay, now we'll come this. Those easily evaporable organic compounds can be or could be removed from the aeration process. So you should know what is aeration process. Aeration means you are supplying air into the water. Because of that, what are the things are happening? When you are supplying air into the water, the air and the water interfaces, both are reacting. When both are reacting, there will be the formation of air bubbles. And those air bubbles, which is nothing but air water interface. When the air interface form, whatever the gases already dissolved in water will be removed automatically without giving any extra thing. That's what we are telling, that dissolved gases removal. Similarly, whatever the ions are dissolved in water like manganese and iron, and those ions are giving some problem to the treatment process, that will be converted into iron hydroxide and manganese dioxide. Those things will be precipitated at the bottom of the aerator, then it could be easily removed by sedimentation and filtration process. And the third problem of water is odor and taste. The odor and the taste will be given by two different substances. One is hydrogen sulfide, another one is volatile organic. And sometimes that odor and the taste is given by some algal byproduct growing in the water. These things will be removed by this aeration process. Now, fourth one is volatile organic compound. The volatile organic compound which are all present in groundwater is benzene, toluene, and trichloroethane. All those things are coming out from the groundwater. The reason for this pollution in groundwater is industrial spill, landfill, and leachate, and some of the chemical disposal improperly, whatever they are doing. So during the runoff or any movement of water which carries these things into the underground water, those organic chemicals or those volatile organic compounds are highly toxic and carcinogenic. even at very low concentration also. So these could be removed by this aeration process. This is another use or following up of this aeration process. And the last one is support of biological treatment process. What is this? Whatever the organic matter is there in the groundwater or in surface water, when you are supplying air into the water, the complex organic matter is being degraded into small organic substances. So this process, such as further treatment stages in water treatment like activated sludge, oxidation teachers, trickling filter, all these are involved in the wastewater treatment. Those will be easy to carry out the treatment process. And also, sometimes the insufficient aeration leads to the poor treatment process, and the sufficient aeration process gives the efficient treatment process, and also economically makes the system feasible. And some of there are different types of aerators are available. In each type of aerators are having that uniqueness to remove one particular substance, that also we'll see later, not now. And this is about the supporting biological. What is the support? The support is complex organic matter is being converted into simple manageable form of organic matter. So the further treatment technology or techniques will be useful after adopting this aeration process. And last one is stabilization and corrosion control. Whatever the corrosive chemicals we have talked about, hydrogen sulfide, ammonia, and carbon dioxide, those things will be acidic in nature, and those acidic chemical will not be removed, means then which forms their respective carbonate and acid, which makes corrosion to the equipments. So that will be managed by this aeration process. And the last one is pre-oxidation for enhanced treatment. When we are supplying oxygen in or air into the process, which makes or enhances the coagulation and filtration process, and which altering the oxidation state of iron, manganese, and other contaminants. So the chlorine demand for the disinfection process will be reduced by other interfering process which involved in the water treatment. These are all the things are generally happening when we are doing this aeration process. So for doing this aeration process, there are different types of aerators are available. What are the different types of, based on the operation, the aerators are classified into normal spray type, diffuse type. Spray means from the name itself you can understand you are spraying something through the sprayer. Like here you are spraying either water or air. And a diffuser means you are diffusing, you are making some flow of air into the water. And a cascade type or step, you are making the step flow of water by providing maximum surface area of water exposed to the air or water. Then you can improve the aeration efficiency. These are all the different types of aerator. That is diffuse type, spray type, and cascade or stepwise, and like that many types are there. One by one we'll see. And limitation of aeration process. I am talking about all the advantages of aeration process, what is happening in aeration process, why we have to adopt the aeration process. But this also has some limitation. What is that limitation? What is that limitation of aeration process? You can actually, organic matters are, there are two types. Organic substance are two types. One type is volatile in nature. Some of the organic compounds are non-volatile in nature. The non-volatile organic substances which are all present in water cannot be removed by this aeration process, because we are doing the treatment. The treatment supposed to eliminate or remove all form of organic substances, and it's supposed to be volatile or it's supposed to be not volatile. All the organic matter supposed to be removed. If partially removed and partially not removed means no use of this aeration, any treatment technology. That limitation, this aeration. Wherever the volatile organic substances are present in water, which should be removed. Non-volatile organic substances cannot be removed. That is the limit. That is one of the limitation of this aeration process. And another one thing is, when we are doing, and when your hydrogen sulfide is from the decomposition process. So the all decomposition process compulsory releases hydrogen sulfide. This hydrogen sulfide removal from the aeration process could be limited when we are doing the softening process. When we are doing softening, whenever you have the hard water is supposed to be make it soften. When you are making the softening process, the hydrogen sulfide should not be there. If the hydrogen sulfide is there, which interrupt the softening process, and if you remove the hydrogen sulfide also, it is not completely removed because this is not completely volatile in nature. That time what people are doing, extra oxidation they are doing along with the chlorine or ozone or potassium permanganate along with the aeration process, then this hydrogen sulfide will be removed highly. Then they can do the normal process. And similarly, this suppose some of the non-volatile organic compound, that is phenol, cresols, and whatever you people said, agriculture residues which is infiltrate or percolate into the water, that is pesticide. Those pesticide and many other industrial heavy chemicals cannot be removed by this aeration process. These are all the limitation of this aeration process. Is it clear? Now you people ask me whatever I said. If you have doubt, I will explain now. I'm going fast because I have to complete this, cover the syllabus. Hello.
Hello, madam.
Yeah, I'm going fast or what's so? Can you understand me? Or can you be able to follow me, or do you want me to explain again? I'm not audible.
It depends on the
You're
individual.
audible, madam.
Yes, madam. We are following.
Okay. So
See, we are following your class and as well as this our university provided study material. So we are correlating this.
okay. Then I may not be talking in that order. I'm talking by my own.
Yes, madam. Some concepts you are adding in better way. So that is also we are getting some notes.
Okay. You listen me carefully.
Madam,
Then you go through your material. It is easy for you to study.
Yes, madam. Yes, it material is like a simple way, but you are going some better and better standard concepts. So yes, we are following you also.
Okay. What I said, you listen carefully. After class, you go through your study material. Then you can easily follow.
Yes, madam. Yes, I will.
Okay, now we'll see what are the types of aerators. There are, I told you, spray types, diffused and packed bed tower, I forgot to tell, and another one is waterfall aerator. Waterfall aerator means I will explain what is that. Because we know now what is aeration, what for we are doing aeration, we know. What are the limitation of this aeration, we know. Now we are going into the types of aeration or type of aerator. The design or the unit used for doing the aeration process is called aerator. There are different types of aerator, which I have already mentioned: waterfall aerator, spray aerator, diffused aerator, and packed bed tower aerator. Among all the four, packed bed tower aerator is having some more advantages than other things. The choice of aeration method is depending upon what are the contaminant type, because there are four types I told. How to pick up the type, which is depending upon contaminant type, required efficiency, energy availability, and space constraints. Based on that, you have to select the things. What we are doing here, when you wanted to get the better performance or efficiency of aerator, you supposed to make very thin film of water, and that thin film of water, when we expose to the atmosphere, and there will be a dispersion of air into the water in the form of fine bubbles, and which employ either the counter current or the co-current gas flow on between the water and the air, then which make the interfaces. Based on the interfaces, the efficiency would be increased, I say. This is the phenomena or the concept of aeration process. For this method, the people wanted to make more efficient, and the design concept is making based on the mass transfer concept. The mass transfer between the water and gas, that is liquid and gas, their mechanism is differ according to the design, operating condition, and treatment as objectives. So based on that only, the types as being classified. First one, we'll see what is the waterfall type. From the name itself, you can understand they are making the water to fall. How to make the water to fall? They are constructing some steps. On the steps, the water is falling. When you are maintaining such a flow at a slow flow rate, the water is exposing to the atmospheric air, that there will be the interaction of air and water, then there will be the formation of air-water interfaces. So you have to make the free fall of water. You have to construct the steps or basin, and which create the turbulence and making the exposing the large surface area of water into the atmospheric air or oxygen. Then the aeration efficiency will be increased. If you increase the fall down height and furthermore increase of efficiency, height means you have to the 5 steps, 10 steps, and 12 steps like that. If you know, maximum 10 to 12 steps only we can make, and which enhance the mass transfer. And for that, people are making either steps or trays or baffles, and they are making a very thin seat. And such a system people are following here. Now I will ask you, here and there in any garden or any picnic spot, you would have seen that water fountain, right? The water fountain, they are using everyday fresh water, or the used water they are using repeatedly. What is happening there? You people would have seen water fountain here and there, is it? And especially in major cities and gardens, they are providing water fountain, correct? No one has seen any water fountain.
Yes, madam. In most of the parks, we see.
Yeah. So what is they are using repeatedly the
Yeah, it is recycled, madam.
Yeah, recycling.
Yeah.
So they are using that water continuously. Could you able to see that is contaminated water? No, no. Every day that looks like a fresh water only, is it? They are following this concept only, and every day their water is spraying and the water is free falling, and they are exposing to the air, and the continuous aeration is happening, and whatever the dissolved gases and organic substances and minerals will be removed by automatically following this aeration process. That water aerator is called waterfall aerator or free fall water aerator. Got it? That everyone would have seen. Next one is coke tray aerator. The coke tray aerator is they are using some sort of granular substance in the trays. There will be a number of trays. You can see a figure in your book, and the number of trays will be there. In each tray, they are providing some of the coke or granules. Coke or granules means what? It is a substance which has more porous in nature. When the water falls on that, and the water will not go very fast, it slowly moves. The surface is not smooth, the flow will be very less. When the water flows very slow, then it is exposed to the atmospheric air too much, and the water flowing in a cascade manner from the top to bottom. And the aeration, when you are providing such a condition, then aeration is being intensified. The unique advantage of this particular thing is freshly precipitated iron and manganese oxide, whatever is there, that will be sitting on that media surface on the coke or granular substance, which accelerate further oxidation. Then it will be completely converted into manganese dioxide and iron or ferric hydroxide. Then it will be removed easily. This system is ideal for treating the groundwater to remove Fe2 plus and Mn2 plus. Wherever this concentration is high, there they are using cascade type water aerator, or it is called coke tray aerator. Coke tray aerator means either coke or granular substances they are filling with the tray. Then through that they are doing the aeration process, nothing else. Then wood or plastic slat aerators, and they have stacked with some of the trays with such a material. Stacked type. They are arranging such a trays which it is very simple and compact. And whatever the technique I told you, the same technique is being followed here. And many of the industrial processes, municipal water treatment, which contain more organic dissolved gases as well as this manganese or iron is more, they are following this wood or plastic slat aerators, people are following. And the next one is forced trough waterfall aerator. Here, so these are all the type waterfall, or you can say tray type of aerator. The second one is spray type of aerator. Spray type means they are using some sort of nozzle. When they are using the nozzle, it has very fine hole. Through the fine hole, the water will be dispersed, and which greatly increasing the air water interfaces, and which increasing the mass transfer. So this kind of spray aerator people are generally using wherever the organic, volatile organic matter is more, hydrogen sulfide, carbon dioxide concentration is more, there the people are following this spray type. When they are using the spray, the water flow speed is more, and they are using very less quantity of water through the spray, because the nozzle means you can understand that the hole size is very small, but which will be emerging out with high pressure. So what the air water interface formation will be very fast, so the more mass transfer will take place, then the removal of such a compound can be improvised. And in that, many types are there: hollow cone nozzle and full cone nozzle. The difference between these two, in hollow cone they are using very smaller droplets. In full cone they are using very more uniform spray and larger droplets. So this is only the difference. If you are using larger droplets, which reduce the aeration efficiency. If you use a smaller droplets nozzle, which makes more mass transfer, so the efficiency would be high. But the nozzle is very small. There will be the problem always in clocking, and high pressure will be required. So we have to think about all our advantages and the disadvantages. What problem is there in particular water source? So that problem will be resolved by following what sort of aerator we have to analyze and select. Even after selection also, while operating, what are the maintenance costs will be required, we have to select and follow this. And next one is air diffuser type. Air diffuser type means they are using in a container very perforated, very small porous pipe or porous plate or fine diffuser type or perforated pipe or perforated sheets people are using. Now here what they are making, the water flow will be there. Air they are diffused through this perforated plate or perforated pipes or fine perforation, and they are making the air bubble, and which highly compressed at a very high pressure make use of what we can say, use of compressors, or you can say another name of compressor is I forgot another name of that compressors. Then the pressure will be high, and the high pressure will induce which makes the air water interfaces more, because we can understand that already water flow is there, and you are diffusing a air through the perforation, and the air you are making from the compressor system, then the pressure must be more. If the more pressure is introduced into the water, the air bubbles, more air bubble will form. If more air bubble will form in the water, then water air interfaces are more. If water air interfaces are more, then mass transfer will be more. Then which dissolved gases, whatever the gases are, the more gases will be removed from this particular type of aerator. So for all the type, there will be a diagram in your book. You just go through it. Whatever the concept I am telling, that only will be followed. The next one is packed tower aerator. Packed tower aerator means there will be a container or cylinder. At the middle of the cylinder, there will be a column. The column is filled or packed with some of the material. The packed material may be some ceramic saddle, or it could be some plastic ring, or sometimes people are using bituminous or bituminous coal, or sometimes in the nut cell, that apricot cell, anything it could be used. They are filling or packed with the middle of the cell. Here, the counter current flow system they are arranging. What is meant by counter current flow? Any one of you can answer what is meant by counter current flow? when the flow is occurring between the solid and liquid, or liquid and gas, or solid and gas, there will be a two ways of flow. One is co-current flow, another one is counter current flow. What is meant by co-current flow and another one is counter current flow? Anyone of you are knowing? Counter current means any fluid or anything, the movement or flow of things in the same direction means that is called co-current. If the flow of fluid or substances are different or opposite direction means that is called counter current flow. Here, the water is injected from the top, the air is injected from the bottom, the water is coming from the top to bottom, the air is going from bottom to top. This is called counter current flow. This counter current flow system, which hits the packed bed in the middle of the system. So in the packed bed which interacts, the water is coming from the top to bottom, air is going from the bottom to top. When it crosses in the packed column, there the interaction between water and the air takes place, and this is called counter current flow. And when they are contacting in that bed, the air water contact or the interface changes are increased in that packed column. Because of that, which increases the mass transfer, so the removal of gases and other things will be happening more in this packed bed column than the other type of aerators. Is it clear? Hello? These are all about the type of aerators. Now we have seen different types of aerators. Then what is the theory involved in that aerators? What is the theory involved in aerator or in aeration process? Till now it is clear. Hello? Okay, what is the theory of gas transfer or theory of mass transfer or theory of this aeration? Suppose we are talking about the aeration process, which is simply supply of air into the water. So it is very simple. We cannot think like that, because there will be a understanding on the designing of aeration. It is very important. It is fundamentally mass transfer process between air and water. Both are fluid. Water can be controlled and air cannot be controlled. And it is working under the equilibrium condition. We keep everything in mind according to the Henry's laws. It states that the equilibrium concentration of a dissolved gas in water is proportional to the partial pressure in the gas phase. When the condition is after that time only, the removal of gases will happen. What is that? The equilibrium concentration of dissolved gas in water, equilibrium concentration of dissolved gas in water is directly proportional to the partial pressure in the gas phase. That is where, what is the gas? The gas, whatever the gas is dissolved in water, that pressure is proportional to the equilibrium concentration of dissolved gas. Whenever this situation is will come, that situation whenever reach that time only the gas removal will be happening. So he has this law is called Henry's law. According to the Henry's law, the equation C equal to KH dot P, where C means equilibrium concentration of dissolved gases, K is a Henry's law constant, and P is the partial pressure of the gases. This process or this law explains whether the gas is stripped out or whether the gas is absorbed. When the what is air? Air is nothing but a mixture of oxygen and nitrogen, is it? So what is the composition of air? Hello? What is the composition of air? Anyone can say air composition? Okay, which contain oxygen and nitrogen, and the gases such as carbon dioxide and hydrogen sulfide can be removed from the water when they exceed their equilibrium concentration. And when the concentration is less than the equilibrium, then it will be absorbed. And this aeration process is controlled by some important factors. Those important factors are contact. One is contact time. Second one is turbulence and the mixing, how it is happening in water, between water and the air. And the third one is air to water ratio. And the fourth one is temperature. So contact time, how it increases, the longer contact time between water and air, which increases the air water diffusion, and it is increases the formation of air water interfaces, and which maximize the mass transfer efficiency. And turbulence and mixing. Turbulence renews the water surface exposed to air, and which disturbs the boundary between the boundary layers that restrict the gas movement. So in waterfall, gasket, and mechanical surface air type of aerator, the turbulence is very primary driver of accelerated gas exchange. Air to water ratio, this is very, very important. The amount of air supplied related to water flow strongly affects the transfer efficiency. Whenever the higher ratio is there, which increases the driving force for stripping process, that means removal of gases, and excessive air can lead to the unnecessary energy consumption. So the optimal balance between the air and water, it is very important. Temperature, another important parameter which influences on aeration process. Gas solubility, always we have to remain, keep in mind, gas solubility decreases with increasing temperature. Actually, we have to, in general, temperature which decreases the gas solubility. But what is our purpose in aeration process? We are removing the already solubilized gases. So what we supposed to do? The stripping process of CO2, carbon dioxide, ammonia, hydrogen sulfide, and volatile organic compound is more effective at higher temperature. So the temperature will be more, the stripping process more, because the solubility will be reduced. While oxygen absorbed or air is absorbed is generally more efficient in colder condition, and this will be increasing the higher solubility. So when it is happening like that, then the biological oxygen demand will be decreased, because the organic matter will be degraded from the complex structure into simple structure. These are all the theory or concept is being involved in aeration process. And the surface area of contact. Air-water interface enhances the potential for mass transfer, and the concept will be involved in fine bubbles, spray, thin water film, packed bed medium, all increases the surface area. So packed bed tower aerator are particularly effective because their packing provides extensive contact surfaces for counter-current gas exchange. So this kinetics as well as equilibrium stage both are playing important role for the mass transfer in aeration process. So the theory and the factors which affect the aeration process is very important question in exam aspects. And when we are discuss about all these things, anyhow, aeration process we are doing for maintaining the pollution level or pollutant level, and which contribute the public health by improving the taste and odor, and preventing the staining through the iron and manganese, and reducing the contaminant the aseptic and health result. So this is very important process. And water quality change is intensified in the industrialization and population process, and which remains central to treatment system. The advances such as energy efficient diffusers, hybrid aeration oxidation units, and smart monitoring technology, and they are enhancing the performance and reducing the cost. However, it has some limitation. Its efficiency depends upon the temperature, water chemistry, and air-to-water ratio. It cannot remove non-volatile organics, pathogen, or many heavy metals. Require integration with the other treatment process. That is a limitation of this process, and the remaining are all positive aspects for this. Aeration is more than mixing air and water. It represents a critical intersection of physical, chemical, and biological process. Its versatility makes it uniquely indispensable for modern water and wastewater treatment, supporting environmental protection, public health, and sustainable resource management. So this is about the aeration process. So aeration is one of the important process in water treatment aspects. If people have any doubt, You can ask me now.
Hello, madam.
Yes, sir. No
Madam,
one was responding. Yes, tell me.
madam, is there any difference between this heat treatment and this aeration treatment? It means
Heat
what
treatment.
heat, water,
No, heat treatment where you have seen, where you have studied.
it means in generally in our household we drink
Okay,
water.
okay, okay. Water.
So what is the difference?
Heat treatment, what you are doing, you are boiling the water to 100 degrees centigrade to kill the pathogens. Whatever
Oh,
the microorganisms are there in water, that you are killing by boiling the water. That is heat treatment.
yes.
Aeration means what? Aeration means what? You are supplying air into the water, which does remove all the soluble gases in the water, and also which removes all the volatile organic matter from the water, and which degrades the complex organic substances into small substances from the water, and whatever the iron and manganese are there from the groundwater will be oxidized into ferric hydroxide or iron hydroxide and manganese dioxide. Because iron and manganese both are in water everywhere on the earth's surface. These
Yes.
two will give the color and taste to the water, which gives positive attributes to the water, that is in terms of taste. And color means if you drink, some staining will come now on the teeth, on the white cloth, and in some of the instruments, those problem it will be creating. Those things will be removed by aeration. And carbon dioxide and hydrogen sulfide. You know what is the smell of hydrogen sulfide? Hydrogen sulfide smell is rotten egg, spoiled egg smell. Normal egg smell itself, it is horrible. And rotten egg, spoiled egg means we cannot smell it at all. Like that smell will come from the hydrogen sulfide presence. Those gases will be removed. And carbon dioxide and the same hydrogen sulfide both are acidic in nature, which will be there in water means which decreases the pH of water into acidic pH. If this acidity is there, whatever the equipment we are using for that water usage or water process, those equipment and devices will be affected by the corrosive problem. All these things will be controlled by aeration. Aeration means we are just passing the air into the water. You are making air water mixture. When you introduce air into the water, what is happening? Air bubbles will come, that is called air water interface. When the air water interfaces are coming, whatever the gases already solubilized or dissolved in water will be going out. are removed. These things are not happening in the heat treatment. There you are simply heating the water by boiling the water by heating. The pathogens, whatever is there in the water, will be killed. That's all.
Yeah, okay.
Is it?
In conclusion, the boiling method is remove the pathogens.
Yes.
Okay. Yes.
It will not remove the whatever aeration it does.
Yes. Yes. Yes, madam. Thank you. Thank you very much. Conclusion.
Okay. Anything else? Okay.
Nothing.
Okay, we have class again at 2 o'clock. Is it?
Yeah, ma'am. Sorry, actually, I don't know what is the proper schedule because
People are there. I can start up the next lesson also because
yeah,
it is the
yes, ma'am. I will follow the link from our WhatsApp group.
Okay, now I will start the 6th lesson. That is about the sedimentation process.
Yes, ma'am. Yes. Please.
Okay. What is sedimentation? As we have discussed already that sedimentation means whatever the particles are there in water which is more dense than water, that will be settled down at the bottom of the container without any disturbance, and this will be happening by natural gravity process, that is called the sedimentation process, which is a reaction between solid and liquid separation. And there is whatever the stabilized particles, we can say that solubilized and high dense particle will be removed by the sedimentation process. And after doing this the sedimentation process, the next process of the treatment like filtration and disinfection or chlorination will be easy, and it will reduce the load, and also further treatment steps are becoming easy. Although it is very simple and the concept is very simple and operation is very simple, and this technique right from the ancient period before 2000 K AC, the people are following this technology, and historically sedimentation is being one of the important process for water treatment, including the those in Rome, Mesopotamia, Carthage, Aden, and Jas systems and reservoir or primitive settling bases are people are following generally. We no need to give any sort of extra energy or anything else. We have to leave the water simply stable without giving any velocity or turbulence, and don't disturb it, and make the water be stable, and due to the normal gravity process the whatever the settling particles are there will be settled down at the bottom. So this process is called the sedimentation process or settling process. The device or the unit which takes the settling or the sedimentation process is called sedimentation tank or settling tank. It is one of the important process in water treatment technology. And the time taken for this sedimentation process is called a detention time. The detention time will be varied from 4 to 5 hours for this sedimentation process. This sedimentation process basically, whatever the particles in water, which is high denser than water, which is settled under gravity, and a settling velocity depending on particle size, density difference, fluid viscosity, and gravitational force. And the large dense particles settle very quickly, and fine colloidal particle will be remaining in the suspension only. That will be having very low settling rates. To enhance the removal of such particles, sedimentation is often proceeded by along with the combination of other process called coagulation and flagellation. Then where the coagulant destabilize this colloidal particle, then which makes the flagullant by aggregating the smaller colloidal particle into bigger one, then it is easily settled down at the bottom, then we can remove it. And there are different types of sedimentation is taking place based on the particle size and the particle how it is interacting with the activation process. Shall we discuss about it now? Hello?
Yes, madam. Yes.
Okay. What is sedimentation? It is very, very easy. Again, I'm saying whatever the particles are presented in water which is heavier than water, those particles will be settled down at the bottom of the water container, by natural gravity phenomena. When we do the sedimentation process, we should not disturb the sedimentation basin or sedimentation tank. We should not provide any velocity or turbulence, anything. We make the stability of water for quite a normal time. The time taken for this sedimentation process is called a detention time. The detention time varied for this process is 4 to 5 hours. Okay. What are the other factors which influencing for this sedimentation process is settling velocity. The settling velocity is what? Settling velocity, which is nothing but when the downward gravitational force on a particle is balanced by the upward dog, or we can say natural buoyancy forces of the fluid. This is called the settling velocity. Many factors are there to, yes, sir.
Madam, in sediment velocity, does it soluble nature will influence that sediment velocity?
The sediment does not have settling velocity is there, not sediment. Sediment means what? Already.
The soluble nature of the material.
What, sir? I'm not getting you. I cannot hear you. What is that?
The soluble nature of the material is also influenced by. Does it influence the velocity of the sedimentation process?
Yes, yes. Because soluble, something is solubilized, something the which increase the thickness of the liquid. Correct.
Yes, yes.
If the thickness of the liquid is increased, means the velocity automatically will be reduced. Correct.
Yes. So if for suppose below the 1 micrometer material may take lot of to sediment.
I will
Or,
tell you. You take water. I will make you to understand that. You take water in one glass. You take thick milk in another glass. Thick milk. You can say thick milk. Now you make the flow water you pour on the ground or flow. The clean water will flow fast. The thick milk will flow slowly only. Correct.
yes, ma'am. Yes.
So the whatever the solubilized material is there in water, that will increase the thickness of any fluid. If we increase the thickness of fluid, obviously which will reduce the flow of that particular fluid.
Yeah. Okay, ma'am. Yes, ma'am. Yes.
Okay. And this will be influenced by particle size, shape, and density, and fluid density and viscosity. Which density and viscosity both will be changed with temperature. Gravitational acceleration, that means gravity, nothing but gravity. So gravity we cannot increase or decrease, but gravity will influence on the settling or sedimentation. Fluid density and viscosity will be, and density and viscosity, what is the relationship? Can you tell me please, what is the relationship between the density and the viscosity? Both will be increased by increasing the temperature. Increasing means the flow. Density and the viscosity will be decreased by temperature. And if it is decreased, means the velocity will be increased. If the velocity will be increased, means then the settling rate or the sedimentation will be decreased. If the particle size is more and the shape is different and the density is varied, all these things will be influenced by or on the sedimentation rate. I'm saying sedimentation rate. The retention period I told 4 to 5 hours. No, that variation will be taking place because of all these things. If the particle is very larger and denser, means then it will be settled down very fast. If it is very small colloidal particle, means it takes long time. And because what is colloidal particle? Anyone can say what is colloidal particle? Colloidal particle means what? Collides or colloidal particle. What is that? Actually, these impurities or the pollutant in water could be categorized in 3 different ways. One is colloidal particle, another one is suspended particle, third one is dissolved particle. The dissolved particle is completely dissolved that you cannot separate out by normal process. Colloidal particle which looks like a suspension, but you cannot separate out by anything. Another one is suspended particles. It is floating in nature that could be separated out by any filters or screening. I told you the initial stage of water treatment, I told you it could be screened out by fine screen or spore screen. Now the colloidal particles are less density than water. Heavier density than water or more dense than water could be easily settled down through the sedimentation process. We can remove that's what it is called the sedimentation process. Some of the particles are less dense than water and they have negative surface charge and they always repel each other. It will not interact and it will not collide. Those particles always suspension in nature in water that cannot be removed by any sort of filtration process. Those particles are called colloidal particles. Is it clear? Is it confusing? Shall I tell one more time?
Yes, madam, it's clear. Go ahead.
Okay, colloidal particles. Those colloidal particles are removed by coagulation followed by flagellation process. Clear? So Stokes' law for particular settling, they are according to the Reynolds number they have followed. And Stokes' law, what is saying, with the settling velocity is proportional to the gravity and the density difference between the particle and the terminal velocity and the diameter of the particle and inversely proportional to the viscosity of the fluid they are telling. And for that, they have given the explanation in your book. It is not very difficult, it is very easy. Stokes' law, it is very important because it is applicable for particles, those who are perfectly spherical and smooth. And this flow, laminar flow, the Reynolds number should be less than 1. And the suspension is dilute, so particles do not interfere with each other. Those are all called colloidal particles. And the fluid is homogeneous and incompressible with the constant viscosity. There is no turbulence, eddy currents, and external forces and other gravities are applied. In such a situation, if you perform the sedimentation process, that process is called Stokes' law, where that formula, whatever they have written, that formula will be applicable to find out the Reynolds number. And the Reynolds, based on the Reynolds number, the Reynolds number less than 1 means that is laminar region where Stokes' law is valid. Reynolds number in between 1 and 1000 means it is transitional region, correction is needed. And Reynolds number more than 1000 it is turbulent region. Again, you have to correct it near a constant. And whenever the Reynolds number less than 1 means, then only you can follow this sedimentation process. Otherwise, you cannot carry out the sedimentation process. If the Reynolds number either it is in between 1 and 1000 or it is more than 1000 means it is in different region. 1 and 1000 mean transitional region and more than 1000 mean turbulent region. So you have to correct it, make the system P very stable, then only you can follow the sedimentation process. These are all the indicators that whether we can follow the sedimentation process in a particular situation or not. That is the importance of this Reynolds number. And deviation from this ideal condition, whenever the system, real systems are there, and that real system means it's supposed to be ideal, it should not have the Reynolds number more than 1. And suppose if the Reynolds number is changed above 1 to 1000 or above 1000 means we have to do some of the correction. What are they? The particle shape and flagellation, particle concentration, and the fluid turbulence and the fluid temperature, all those things we have to correct it. In such a way, we can make the system to the ideal to carry out the sedimentation process. What is the particle size? Natural particles are very rarely spherical or elongated or plate-like shapes. And whenever they are having such as shapes which reduce the settling velocity. Flagellation means what I said, whatever the fine particle which is less dense than water, those are all called colloidal particles. Those are not stick together, but you have to make them stick together by adding some coagulant, then forming these small particles aggregate into this larger one, and you have to make them to settle down very fast and predict it. And the particle concentration, if the particle concentration is very high, and those particles are interfere with each other settling, so which lead the different types of settlings are there. One of the type is third or be settled down. If the turbulence is there, turbulence means mixing, and we are aggressively whatever mixing, that is called turbulence. Then there will not be any settling of particles. So we have to correct the system to reduce the speed or turbulence in the water system to undergo this ideal or to achieve this ideal condition. And the temperature, always temperature affect the viscosity, so reduce the viscosity and also density. And warmer water lowers the viscosity. If the viscosity is reduced, mean then the settling or sedimentation will be increased. And there will be a different types of thing that we'll see later. First, we will see what are the types of settling or sedimentation. Based on the size of the particle and the concentration of the particle in water, there are 4 different types of settling or sedimentation is taking place in general everywhere. And we may not know, even when we are cooking and we are keeping the things at home also, any one of these 4 types of settling is happening. What are they? And particle settling behavior depending upon the concentration, particle characteristics, water chemistry, and the hydraulic. Hydraulic means whatever the pressure or velocity inside the container. Based on that only, this sedimentation or settling is taking place. Engineers classify this sedimentation in 4 different types. One is free settling, second one is flocculent settling, third one is hindered or zone settling, and the last one is compression settling. And each type has a distinct mechanism and a practical application water and wastewater treatment. Each type is being followed. First one is free settling or discrete settling. From the name itself, we can understand that free settling or discrete settling is happening whenever the particle concentration are very, very, very less. Here, each and every particle are settling with it individually or independently. Here, there is no interaction between one particle with another particle. It is typically happening very dilute suspension or very dilute concentration with less than 1% solid concentration. That time only this discrete or free settling is taking place. And each particles are settled down individually. There is no compound settling or the mass settling is taking place in this particular type. And a sand trap, grid chamber, those are all examples of this free settling or discrete settling. Next one is flocculent settling. Flocculent means what? Flocculation I have explained. Colloidal, whenever the colloidal particles are there in water, listen me very carefully, this is very, very important. Whenever the colloidal particles are there in water, it cannot be separated out by filtration or sedimentation process. That time we have to add the chemicals, special chemicals are called coagulant, such as aluminum sulfate or ferric chloride or ferric sulfate. When we add, these chemicals are positive surface charge particles, but the colloidal particles are negative surface charge particles. So always the same charge particle will be repulsing each other. Because of that, the colloidal particle, whenever present in water, will be repelling each other. There will not be any collision or sedimentation is taking place. Now, when we introduce into the positively charged particle, this positively charged particle attached with the negatively charged colloidal particle. So one by one will be come and join, and it will be aggregated from smaller size to bigger size. And finally, they will make the gelatinous precipitate. This gelatinous precipitate is called a flocculant. And that flocculant process is taking place whenever the particles are moderate to high solid concentration. And usually 8 to 10% concentration is there, this flocculant settling is taking place. And when that closely come and attach, and they make the group of particle, and their size is being increased slowly or aggregated the size, eventually then the particle size will become more or big, then the particles are looking like a gelatinous precipitate. That is gelatinous precipitate will be settled at the bottom or in the middle, then we can easily separate it out. This is called a flocculant settling. Clear? And this flocculant settling is very, very important. And flocculation, coagulation, and the secondary clarifier handling the biological flux. And most of the industrial effluent system treating colloidal suspension are following this flocculant settling. And the third one is hindered and zone settling. Hindered and zone settling generally occur at moderate to high solid concentration. Actually, moderate to high concentration, 8 to 10% are happening in hindered or zone. Flagellant settling is happening whenever the high concentration and when the water slightly high concentration, that time only flagellant. 8 to 10% means hindered or zone settling. And here what is happening, the particles are very close together and they are settling as a group, not individual entity. And clear interface formed between the settling zone and the water above. So here the settling is depending upon the behavior of the mass and individual particles. Zone settling is common in secondary clarifier. These are all the wastewater treatment, not here. So no need to write all these points. Poor control sludge concentration, return rates, less returns and time essential to avoid problems such as bulking. Those things are no need to write. You have to write what you have to write for hindered or zone settling. This is happening whenever the moderate to high solid concentration, usually 8% to 10% or more, particles are come closer together and they settle as a group, not like individual particles. A clear interface forms between the settling zone and the water above. The settling velocity depends on the collective behavior of the mass, not an individual particle. Zone settling is common in some of the things wherever secondary classifier, activator sludge process, and microbial flux settlers a plant. These places generally this zone settling is happening. And the last one is compressed settling. Compressed settling, whenever the concentration is very high, that time only this compression settling is happening. And most probably in a real system where the clarifiers and the sludge thickness are there, that time they are using or following this technology. Particles are in direct contact and the weight of the sludge plant compresses and may make the lower layers at the bottom of the tank, then it can be easily removed by compression technique, or you can easily remove it by cleaning, normal cleaning and washing. And comparative perspective, what are the types of settling and how it is influenced in a comparative way, we will see now. Classification of sedimentation into 4 types, and it is being highlighted. Low concentration means it is a free settling dominates, governed purely by particle physics. Interaction increase, flagellant settling is happening, and which is accelerate the chemical and biological aggregation. Higher concentration means zone settling, and finally, when the extreme concentration is there, then compressor settling is taking place. And we can say in any high volume settling, all the 4 settling types is happening. Compulsory, the last type of settling also is happening. This is about the types of settling. And design and the equipment means there are different types of equipments are there for settling or sedimentation process. Hello. Hello. Hello.
Yes, madam. We are.
Now we will continue or we'll stop now.
Yes, madam. Go ahead. I'm following you, class.
Okay, there are different types of sedimentation tanks are there. They are horizontal type, circular and radial type, and contact clarifier. About the clarifier, I not tell. I will tell clarifier also inclined type, and the sedimentation system with the baluster and the settling basin, lagoon and ponds, modern mechanical features. Before you know that what is clarifier, we know clarifier is a device where after coagulation and flagellation, you have to separate the clear water from the sludge. That device is called clarifier. Clarifier is a device which separates the clear water from the sludge. And the detention time is varied from 1.5 hours to 2.5 hours. In some of the unit, both the coagulation, flagellation, and clarification is taking place in the same device. In some of the unit, it is separate. But whatever it may be, the clarifier is supposed to be non-disturbed. there will be very less velocity of 20 to 30 centimeter per second, and we can treat the huge quantity of water, which is nothing but you have to leave the water stable without any turbulence. Then all the particles will be settled down at the bottom. We can select it or collected for the uses. So that is clarifier. So that is also one of the type they have told. Horizontal type, circular radial type, solid contact clarifier, inclined type, and all these are all the uh, type of sedimentation tank, or you can say settling tank, or you can say that is sedimentation process unit. Role of coagulation and flagellation in sedimentation. What is the role? Sedimentation, I told you, plain. There are two different types of sedimentation. One is plain sedimentation. Another one is sedimentation with coagulation and flagellation. Plain sedimentation means whatever I have spoken. Leave that water for stable, and whatever the particle more dense and water will be settled down at the bottom, and by gravity, that is plain sedimentation. And the sedimentation with coagulation and flagellation means whenever the particles are less dense water, and those particles will be settled down by supplying some of the chemicals called coagulant, and followed by aggressive mixing, then leave the water for stable for some time, then which makes the gelatinous precipitate called flog. Then the flog will be settled down, and it makes the precipitate. Then the precipitate will be removed. Then we can do the process that is called sedimentation with coagulation and flagellation. What is the role of these two substances on sedimentation? In detail, we'll see that. We'll start class at 2 o'clock, is it? We'll start the class at 2 o'clock, right?
Okay, madam. Madam, by the way, hello.
Yes, ask me.
Madam, may I know your introduction? It means I missed the first class.
So for your set, last year I have taken. Last year I have taken what biochemistry I have taken. And
Okay.
this semester, this is the first class. I am Dr. Vasanti. And
Okay.
I am handling water and wastewater treatment, also air pollution and control technologies. And what is wastewater treatment only I have explained. In the afternoon, we'll see what is the air pollution and control technologies. Okay?
Okay, madam. Nice to meet you. Thank you very much.
Okay. We'll start at 2 o'clock according to the schedule.
Yes, madam. Yes, definitely.
Thank you.